Now we are going for the microstrip antenna. So here microstrip antenna, from the basics we will start. Okay, what is microstrip antenna, why it is required, what are the advantages, disadvantages, and then we are going for the various type of feed, what are the various types of feeds in this antenna, and how we can go ahead. So here we can start. So in the microstrip antenna, it is a microstrip antenna is a low profile antenna. So that is what it is, a very compact and low profile antenna. It is conformable to the planar and non-planar surface. What it means conformable means if you will have a surface, suppose this is a dome-like shape surface. So the antenna is it can be of this shape. So in maybe in various recent devices, the microstrip antennas are used in your mobile phone. Microstrip antennas are used in your aircraft. There are around 70 antennas, 70. Maybe in the domestic aircraft, some little less, but in the fighter plane there are more. And most of these antennas are the microstrip antennas, because the surface of the uh, plane is important because it affects the aerodynamic property. So it is conformable, but it is a planar structure. Okay. So then it is inexpensive. So whatever the printed circuit board technology, that is PCB technology, whatever the PCB we are using for various circuits. So with a different substrate, means whatever the PCB, that is dielectric, or that a copper layer is there, and we do the etching and we have a track. So similarly, antenna can have a etching and can have a shape of the antenna. So this is as this is the not very expensive, so you can do the manufacturing, as in the various colleges it is also available. So the main advantage is this. Then compatible to MMIC. Now what is this MMIC? So that is the microwave integrated circuit. Microwave integrated circuit, and in that monolithic microwave integrated circuit, MMIC. So there are the microwave application. You can have the integration. Previously we don't have the integration. We are using the separate devices, maybe up to few gigahertz. You can have a transistors also, BJT, FET, MOSFET also, and vacuum tubes mainly used for the generation of the your microwave signal. But here, so nowadays there are gun diode and the others can generate a microwave signal, although the power is less. But here, this antenna is compatible with the advanced technology. So integration of the circuits, although it is very easy for or compatible for the lower frequencies, but for the high frequency, RF frequency, and micro frequency, it is somewhat difficult to have uh, uh, this integrated circuit. So the substrate used for integrated circuit and material is the special material. So this is a separate subject of discussion, that is the microwave integrated circuit in that monolithic microwave integrated circuit. So one is HMIC, that is hybrid microwave integrated circuit, and another is the monolithic integrated circuit. So it is more compact. So this antenna, microstrip antenna, has a compatibility with that. So this is also the important thing. And the most important thing of this antenna, the advantage is it is the reconfigurable antenna. Means what? We have various parameters of the antenna that we may have discussed. So you may have the frequency, that is the resonance frequency. So one antenna having the resonance frequency at this, and the another is this. Suppose if I want to use a single antenna for two different applications, but not at a time, at different time, maybe on time sharing basis. So what happened? This same antenna can be used for the different frequency application. So this is called the frequency reconfiguration. Means suppose one frequency is 2.4 gigahertz. So this antenna is tuned to 2.4 gigahertz frequency, and then when it is required by some arrangement, so you can have the pin diode or the varactor diode. By using that arrangement, you can shift the frequency either to higher or lower. If suppose one example 2.4, and then you can say shift to 3.6 or whatever is required. So accordingly you can design antenna, and single antenna can be used for the two different frequencies at a time. So it is what the advantages. So multiple antennas can be reduced to the single antenna. So this is what regarding the frequency reconfiguration. Here what I'm saying, this is the frequency reconfiguration. So frequency reconfiguration is the one thing. Then second is the impedance and polarization. Now the impedance, what is the impedance? Now generally nowadays for the antenna input, there are standard impedance that is 50 ohm, but sometimes there may be 75 or 100 or something else. So that also we can do the multiple impedances can be connected by using this antenna, maybe input or output. Then next is the polarization. Now there are generally prominent two type of polarization. One is the linear polarization, another is the circular polarization. Now in the circular polarization, it may be left-handed circular polarization or right-handed circular polarization. Left-handed polarization means what? Your electric vector, E field, how it is rotating. Okay. So if your electric field vector in linear polarization, it may be horizontal. So electric field vector rotate horizontally this way. Or you may have the electric field vector rotate vertically this way. So this is the linear polarization, but one is the horizontal, another is the vertical. So you can change the polarization from vertical to horizontal or horizontal to vertical. So this is again the one type of the reconfigurability. So that is available. In the circular polarization, you may have the anti-clockwise rotation of the electric field vector or clockwise rotation of the electric field vector. So it is very much important that in the circular polarization, there must be a polarization matching between transmitting and receiving antenna. So to achieve this, we can have the different polarization also can be achieved by using the various devices. As I told here, that is MMIC technology is compatible. So here by using MMIC or HMIC, simply having the pin diode or the varactor diode, you can do the frequency reconfiguration, then impedance as well as polarization reconfiguration, that is variable impedances, variable polarization can be achieved. So these are the advantages or the introduction for the what your antenna, that is the microstrip antenna. Now we will go for the next. Now what may be the disadvantages? Okay, so here your disadvantages is low efficiency. Now efficiency means what? Whatever the input power you are giving and how much output power you are getting. So ratio of that output by input, that is the simple concept as we know. So this antenna, as it is the planar structure, uh, power handling capacity is low and having the low efficiency means the gain such antennas gain is comparatively less. Low power, as I told, the low power. So power handling capacity is less as these are the compact antenna. Only PCB like structure is there. So PCB like structure, the copper layer is a few microns. So due to that, the power handling capacity of such antenna is comparatively less. So you cannot use the microstrip antenna for very high power applications such as maybe transmitting station of the satellite. So when you are to transmit a signal, suppose a geostationary satellite, so if the signal should travel for 36,000 kilometers, but to travel a signal for 36,000 kilometer, you need a proper power. So the microstrip antenna cannot be used there. So it is having the low power handling capacity. Then the next is the high Q quality factor. So quality factor, it is inversely proportional to your bandwidth. So if you will have the high quality factor, then you will have the comparatively low bandwidth. So quality factor is high. Then poor polarization purity means there is the cross polar component. Cross polar component, in the cross polar component, what you have that whatever the polarization, it should be purely linear or circular polarization. Mainly it is on the circular polarization way. So your electric vector, it is rotating in this manner. Okay, it creates a circle. But if this is creating, suppose I'll just show you here, if this is your electric field vector, okay, this is what your electric field vector, and if it is rotating in the clockwise manner, so this is, it should be ideally this way, it should rotate, and equally it should be there. Okay, so it is rotating in all way. So if all these vector, electric vector, they are rotating in this way. Okay, so if the magnitude is same, then it will be create a circle. But if you will have this one side, if this is not a exactly equal, if this is less, suppose this way and this way, so what here, it creates a ellipse, not a circle complete. So if you will see here, so here instead of circle, this is what a simple the ellipse, not a complete circle. Okay, it should be like this for a complete circle, but it is the elliptical, it is like this. Okay, so this is what it may not have the proper circular polarization. So polarization purity may be the issue, but we can address these issues. Okay, then poor scan performance. So scanning the antennas, some antennas maybe your radar antennas, so they are using to scan a target. So generally the parabolic reflector antennas are used. So this microstrip antenna, it is having the poor scanning performance to track a target. Okay, so this is what one of the disadvantage. Then spurious radiations and very narrow frequency bandwidth that I told previously. Spurious radiation means what? Here, the spurious radiation means if you are having an antenna, suppose this is the antenna, okay, and on the antenna, you will have a structure. So this is what a patch, okay, this is what a patch. But to feed a patch, you need some feeding technique. So you have to feed this patch. Now, actual your patch, radiating patch is this. Okay, radiating patch is this. But you are feeding by this line. So as this is the antenna, this is radiating and this is also radiating. So this is not the required radiation. So this may be the spurious radiation, the unwanted radiation in the unwanted direction. So this may cause, so this may create a, what you can say, the disadvantage. This is one of the disadvantage. So these are some of the disadvantage, but with all these disadvantage, it is very convenient antenna. It is very convenient to use and very popular antenna. Mainly, this is what very popular antenna. So from so many years, this antenna is used. So now we will go for the structure of this antenna. Okay. So far, is there any question? I don't think so, because this is the
No,
simple
sir.
thing. Okay, these are the simple things. Now here, this is what a structure of this antenna. As I told here, this is a patch, and this is what the feeding line. Now, what is the performance? What are the things? Now, as we discussed previously, every parameter of antenna is in terms of the lambda. This lambda zero, that is the free space wavelength. That is the whatever the frequency. Then you will take the speed of light, so you will get the free space wavelength. Lambda equals to c by f. So this is what lambda zero. Now what the parameter, now thickness, this is what the h, this parameter is h, that is the height of the antenna. So this is very planar antenna, very height is very narrow. Okay, height is very short height antenna, maybe in this range 0.03 lambda 0 to 0.05 lambda 0. So this is what the height of antenna, that is this h parameter. Then the length, this is what the length and width of the antenna. Okay, so this length of the antenna, it is in terms of the lambda, so it is lambda by 3 to lambda by 2. These are some standards, general consideration of the antenna, that what I am discussing. So what this is what your entire the structure is, what this is what your PCB like structure, and this is what your patch. Okay, so as this is written, this is the substrate. So this is upper patch, that is the copper patch, copper. This is what the copper plate, what it is shown here. Okay, and this is what the substrate. So the entire, maybe the plastic type FR4, or FR4 is the generally used as a substrate, general substrate for the comparatively lower frequency. And this is what the ground plane, the thick black line, this is the copper plate. So double sided PCB, if you will see, so the ground plane is the complete PCB structure. On the bottom side, that is complete a copper, and the top side, depending upon your requirement of the frequency, that is the resonance frequency, this structure is designed. So how it is designed, this is the depend on the height, that is the h, the length. So the length is in this range, that is lambda by 3 to lambda by 2. This is what the length, and this is what the w. Okay, so w is the width. So the width is calculated according to the frequency of resonance. Then this is epsilon. This is what the substrate. As there are various types of the substrates are there, that is substrate dielectric constant is there. So this dielectric constant, it may be from 2.2 to 12 in this range. So depending upon the requirement, there are various advantages and disadvantages for using the substrate. So if you will have the very high value substrate, the very high dielectric constant, then you can design a compact antenna. But there are certain disadvantages also for that. So this way, depending upon your application, you can choose, and sometimes maybe on the based on the availability, you can choose what type of substrate you have to use. So this is what the substrate. Then this is what the cross-sectional view of the antenna. Now this is the top view. So as I told, this is the patch, this is the substrate, this is the width of the line, and this is the length. Now how the electric fields, what is the way electromagnetic fields will be there. So this is this arrows are shown. This is the electric field. So this line is electric field. So there is some portion is in the air. So here it is shown from the substrate, from the patch, it is going inside the substrate, and this is what your ground plane, and this is what your upper patch. So here this is what the link, that is the electric field intensity line of forces. So this way the electric field intensity will be there. So this is going upward and it is going downward. So complete loop it is forming. And this is what the dotted line, this is the magnetic field vector. So this is magnetic field vector H. So this way it is forming the round. So this way across this antenna it is forming, this is electric field vector. So this is what the standard design of the antenna. This is called the rectangular patch antenna. This is what the basic antenna. Now, what are the other possible shapes are available? So there are various shapes are available. Some of the shapes I have mentioned here. So rectangular is the general antenna. For the basic calculation, it is used. Maybe the square, you can have the square shape. You can have the dipole. This is what the straight like a dipole structure. Circular is the again the one of the basic structure. Elliptical, triangular, then the disc section, uh, then the ring, circular ring for the various double band, triple band, or the some very variation in the parameter. This ring type structure is used. We have designed one antenna and given it to the industry. It is ring type structure. We have used the ring for improving the gain of antenna and narrowing down the uh, beam width. The requirement of the industry was to narrow down the beam width. So we have narrowed down the beam width and maybe the ring section. So these are some of the some typical geographical pattern can be used for the microstrip antenna. Apart from that, there are some complex also and that are also used. So this is the patch structures only. Now we will go for some popular feeding technique. Feeding technique means how the antenna is given as the power supply. Because if you will see, you will have uh, transmitting. Suppose if you are saying the transmitting section, so antenna is the last section. So you will have your signal, then your modulation system, then your power amplifier, and all these things, and then the signal is given to the antenna. If in the receiving section, very first section is the antenna is receiving, and then it is giving the low noise amplifier, and then it's detector section, and then demodulator, and then signal is detected. So these are the general things. But how, what way? Now the physical means that how the antenna can be connected to the input, if it is the transmitting antenna. Receiving antenna also the same. So these are the four way. There are many configurations that can be used for feeding microstrip antenna, but these are the most popular four. And out of these four, two are again the most popular. These third and fourth are very rarely used because they are somewhat complicated. So very first is the microstrip line, and the second is the probe feed. So in most of the application, these two are used, and these three and four are rarely used for some specific application if the application demand, because these are somewhat complicated. So what is this? We will try to understand what is the microstrip line feed, what is probe feed, then aperture coupled field, then proximetry coupled field. So these are the feeding techniques for the antenna. So we will see one by one. So very first is what this is microstrip line feed. Okay. Now in the microstrip line feed, this is what the technique. This is microstrip line. So as this is the patch antenna, so you can have a microstrip line. Okay, so the microstrip line is given here, and this is what the microstrip line feeding. Okay, so this microstrip line, it can be used for the feeding of this antenna. Now actual patch is this much is patch. This lot is for the impedance matching. And here you can have maybe mostly the SMA connectors are used. They are the small in size. So these SMA connectors are connected here, and by the coaxial cable it is given here. So from the patch end, because generally the ground plane structure is considered as the larger. This ground plane is comparatively larger as compared to the patch, because the ground plane has some prominent role to reflect the signal to the front side. So it will give the generally maybe the um, directive pattern for your antenna radiation. So this is what a line structure. Now for this microstrip line, uh, how you can use it. Okay, so there are this is what the microstrip line equivalent circuit. So this equivalent circuit like a transmission line. So microstrip line is having equivalent circuit. This is a conductor, resistor, inductor, and this is capacitor. So as a strip line, microstrip line equivalent circuit is there. Similarly, this is again the equivalent circuit for the microstrip line. So this way it is done here. So this is what the popular feeding technique. All the other parameter remain same. Only we have to take care for this how much it should go inside. So these are the calculation for finding out the impedance matching. Then the next is what the probe feed. Probe feed means here what the coaxial cable is connect here. So what is it is a cross sectional view of the antenna. So this bottom, this is what your ground plane. Okay, so this is what ground plane, and this black one, it is the upper patch. So what happened for the upper patch, you have to connect through a hole, means you have to do the drilling a hole through a PCB, and whatever your center conductor. Now in the mainly your coaxial connector or your coaxial cable, you will have a center conductor in any coaxial cable. Generally this is what structure, maybe one center conductor is there this way like structure, and the another is what outer conductor, and the outer conductor is of this way. So this is what the coaxial cable structure. Okay. So this center conductor is feed. This center conductor is feed to the patch. So this for this patch, the center conductor is feed. And whatever this shielding type structure here, it is a shielding type structure across view. This is what shielding. Okay, if you have seen a copper coaxial cable, so there is a jolly type structure, a shielding structure. So this is what. So this shielding structure, this is connected to the ground plane. So here it is connected here. This okay to the ground plane. To the ground plane, it is connected here. So the ground is connected to the ground plane, and the center conductor is connected here. So this is called the probe feed. Okay. So this is what the probe feed technique. So this probe feed technique is used. So that's why maybe any patch. So here it is shown a circular patch. You can have any patch. And again, the probe is having the same equivalent circuit is same as the previous, as it is the transmission line. So this way, this is what the equivalent circuit for the probe feed, microstrip feed. So this is what equivalent circuit. So you require to draw this, and you can explain based on this discussion. Okay, this is the second technique. Then we will go for the third technique. So the aperture coupled technique. Now in the aperture coupled technique, what happened here? This is what one substrate epsilon R1. So here two substrates are there. Epsilon R1, the upper substrate, epsilon R2 is the lower substrate, and between these two substrate there is a feed line. Okay, so the feed line is in between these two substrate. So whatever the dotted line is shown, so it is between these two substrate, and the upper this black portion, this is what a patch, and in the patch here this is the slot. So by a capacitive coupling, this is connected here. So here this strip line is not directly physically connected, it is capacitive coupled. So here this is what the capacitive coupling, this is what the capacitive coupling is there. So this way whatever this feed line dotted line is connected, and whatever you see this portion outside, this is the ground plane. Okay, so this way it is the indirect coupling. So why it is required, why we require this? Because in the previous, as we say this previous, here it is having the spurious radiation. in what microstrip line. So this is what the additional part, and it disturbs the radiation pattern. So I don't want this additional part. I don't want. So what should do? That is, this whatever the feed line I have to hide, it should not radiate. So it is kept between two substrate, and it is not at all radiating because it is inside. And this spurious radiation is avoided, unwanted radiation is avoided in this technique. Okay, and this is what its equivalent circuit. So this way, this is what the technique here. And it is rarely used because to do this and to design all this, so it is what somewhat complicated process. Similar to this, the next is the proximetry coupled. So in the proximetry coupled, the ground plane is not there as shown in the previous, only that difference. Again, it is between the two substrate, that is epsilon R1, epsilon R2. Between these two substrate, the line is there in between. So that's why it is shown by a dotted. Again, it is the sorry, it is the microstrip line. So it is in a microstrip line, and this is what the patch. So this is again, it is the capacitor coupling. So through a capacitor coupling, it is coupled. So again, physical contacts are not there. So this is what regarding the coupling, the feeding techniques. So these are important as per the exam point of view. Is there any question? Okay, so we will stop here.